This is my rendition of an Edison bulb lamp, but in a wine bottle. This bottle features a 120 watt equivalent output, handcrafted construction with bare copper, singed tweed rope, and a magnetic on-off switch. Wait, did he just say magnetic switch? Yes. In order to turn this lamp on, you simply insert the cork into the wine bottle. The magnet attracts an arm that connects the circuit with an extremely pleasing audible. Follow along with me and I will walk you through step by step on how to create your own lamp in a wine bottle. This project is not for the faint of heart. There is a lot of hard work involved and it's extremely difficult. However, if you stick through it, you'll have an incredible result at the end. So let's go ahead and get started. For this project, I used some standard LED light bulbs from Walmart. However, you're more than welcome to use some LED filaments that can be obtained from Amazon or eBay. So I headed down to my least favorite store in the world and I arbitrarily picked out these Edison bulbs. There's like 100 different kinds there. They had 4 filaments and they were clear, so they seemed like a winner. We're going to need a lamp cord, so that just came in the form of an extension cord that I'm going to chop the top off. This sisal rope, I thought it was tweed, but whatever, it looks cool. And then we're going to need some 18 gauge wire. We will also need some 14 gauge wire. You might have to go to Home Depot for that. And I'll explain why we need that a little bit later. Now there are a lot of different wine bottles to choose from, but we really only need a wine bottle that fits 3 categories. First, it needs to be clear. Second, it needs to be large enough to show some LEDs inside. And then thirdly, it needs to have a cork top. A screw top is just not going to look great. I just found the absolute cheapest bottle that matched all these specifications and it came out to a grand total of $14 or $15. The last special item that we need for this bottle is going to be a glass cutter, and I was able to get this one from Ace Hardware. Now that we have all of the parts for this project, we can go ahead and get started. The first thing we're going to do is pop the top on that bottle and pour out this horribly disgusting wine. I did try some because I don't support alcohol abuse, but ugh. It was really bad. With all the wine out of the bottle, we need to get the labels off. I used some hot water and a razor blade to scrape off the main portion of the label, but don't try to get the glue off with the razor blade like I did. Eventually I wisened up after 20 minutes of doing that, hopped on Google and figured out if you mix equal parts of baking soda and olive oil, it takes that glue right off for you. You might think cutting a bottle is pretty difficult, but it's actually really easy. What you need to do is mount your glass cutter about 1.5 inches up from the bottom of the bottle, and we need to score the bottle, just one score. We need to have this score line perfectly match up on the other side. So if you're not sure if your surfaces are level, use a Sharpie instead to check to make sure that the lines perfectly match up. Once we've got our glass cutter mounted, we can begin to turn the bottle, apply even pressure, and you're going to hear a very awful scratching sound. And you'll see the score line left behind and you'll know that you're doing a good job. Do not score it twice. It does not help and it actually makes it worse. You're only going to want to score this one singular time. With the bottle scored, all we're going to do is pour boiling hot water on the bottle and make sure we pour it around the entire surface of that scratch line that we made. And then we just switch to some cold tap water and do the same process, and we're going to do that until the bottle breaks. It's super easy and very fun. Watch how it breaks here. It's so awesome. Oh, that's the best one I've done. Be careful because this cut line is very sharp. What you should do is sand it, but I didn't have any sandpaper, so yeah, you'll see later. With the wine bottle getting all the attention, the light bulbs were feeling a little bit lonely. Let's go ahead and break those out, and I'm going to put them inside of a bag to contain the glass because we're going to pop these bulbs open with any piece of metal that you can find, but you need to be careful because if you hit too hard, you can wind up damaging the rather fragile LED filaments inside. Now, once we've got it open, we need to take very special note of how these LEDs are wired. For this particular bulb, they were all wired in series. We also need to figure out which wire is positive, which one's negative, where the AC hot goes to, and where the AC neutral goes to. Lastly, you need to locate where the polarity marking for the LEDs is. On mine, they had a little hole that indicated the positive side of the LED. All the aforementioned information will be obtained as you take the bulb apart. For the first bulb, I recommend you go very slowly and write down everything as you see it. I'm not going to post how my bulb was wired because I've taken apart 4 or 5 different bulbs and they were all wired just a little bit differently. You need to pay attention to what's going on. With the delicate filaments out of the way, we can channel our inner Hulk and get to work on the rest of the light bulb. We need to extract the circuit board. I use pliers and angle cutters to get the rest of the bulb open. These filaments attract a lot of dust and dirt, including the glass shards from the bulb that we shattered earlier. Use some compressed air to clean them off so you don't get glass in your fingers like I did. Now, this part was a little bit tricky. I'm trying to decide how I want these bulbs to fit inside of the bottle. However, I have to keep in mind that these LEDs need to be wired in series. So it's a trade-off between cool looking and really hard to wire. With that out of the way, it is time to write down some dimensions. I chose to 3D print a base for this bottle because, well, what would a DIY project be without 3D printing? We need to know the inner diameter of the bottle, the outer diameter of the bottle. We need to know about how high up in the bottle we want the base to sit. I chose about 1.5 inches from the bottom. We need to know the thickness of the lamp cord, and we also need to know the thickness of the rope that we're going to use. 3D designing the base for this bottle was fairly straightforward. I first started by pulling up my favorite Trapped in Japan video for some background music. I entered the outer diameter of the bottle, and this is going to be my base. I made it exactly 2 rope widths high, and you'll see why later in the video. I then added a relief cut so that we can get that power cord into the base. The top part of the bottle is just the inner diameter of the bottle, and then about 20 to 30 millimeters high, depending on how high you want the base to sit inside the bottle. You want it to be enough room so you can get the electronics in there, but not so short that you have to cram everything in. I added a taper just to make sure that it would fit on the inside of the bottle very nicely. Then to finish it up, I added a couple mounting holes, and I didn't want to mess around with threaded inserts or anything, so I just made the holes a little bit smaller than the M3 screws that I'm going to be using, and I'm just going to tap those into the plastic by not using a tap and just using the screw. It works. I also took care to make sure that the screws were inset into the base so that it will sit flush on any surface it sits on. With the base done, I sent it over to my 3D printer, and I will spare you the time-lapse video and just show you the end result and hope that you don't notice I switched over to my cell phone camera for this shot. Now, these wine bottles aren't perfectly circular, so I made the outer diameter of my base a little bit smaller than the inner diameter of my bottle so that I could then use some electrical tape to make a nice press fit against the inner side of the bottle. I put the base in, and I used a piece of red tape to mark how high that base sits into the bottle. This is very important because this is going to be a reference point for a lot of things we're going to do later. Moving along, we can get started on that magnetic switch. Now, this part is a little bit hard to explain, so I'm going to let the visual cues help you out with this one, but I outlined the bottle on a piece of paper to give me a guide of where to bend my wire. The wire needs to be long enough to come all the way out the end of the bottle, and we need to have it very straight. I took the wire and I bent it over, making a circle that is the same diameter as the inside of the neck of the bottle. This is very important. It needs to be the same diameter as this hole. If it's too small, you're not going to be able to fit the rest of the magnetic switch mechanism into the bottle. You can see here in the video how the wire is long enough to come out the end of the bottle, runs up the seam of the bottle, and creates a hole that is almost perfectly in the center of the bottle. And this loop is choked all the way up as high as we can go into the bottle before we get into the neck. To make the second part of the magnetic switch, we're going to take a length of wire that is about 3 times as long as the neck of the bottle. It doesn't really matter how long it is, we just can't have it be too short. We can always cut away wire later. Using my pliers, I created a triangle. For clarity purposes, I'm going to call the triangular piece the arm and the circular piece the receiver. The reason I made this piece a triangle is because it accomplishes 2 things at the same time. The first one is it always centers it in the middle of the circle of the receiver. The second thing is we always have 2 points of contact on our switch, that way we always have a very crisp on and a very crisp off. After I had both pieces, I began testing the fit to see if it would work, and I realized that the receiver was bending too much. I feel like over time this would warp and make a bad contact. So I went to Home Depot and I bought some regular household 14 gauge copper wire, stripped off the insulation, and I made another receiver out of this thicker wire. You can see now that it's bending much less, and I feel like this is going to be strong enough for the switch over the lifetime of the lamp. Once I felt like the arm and the receiver were a good match, I soldered shut the hole of the receiver. This receiver needs to get glued on the inside of the bottle. I bent the end of it out just a little bit to help me with positioning it inside the bottle because it's really difficult to jam your hands in the bottle, put tape down, and keep it in the right spot. I used clear Scotch tape here as other tapes leave residues and I didn't want to have to clean that out later. I also put tabs on the end of the tape so I had something to grab and to remove the tape because it's really difficult to get the tape out of the bottle once it's all the way up in there. You'll need to have the bottle held still while you do this because you're going to need to have two hands inside the bottle to get the receiver taped down in the right spot. The bottle, in addition to not being perfectly circular, has two seams on either side. We're going to glue the receiver along one of these seams. Make sure you get it positioned properly so that the hole that you made earlier lines up with the neck of the bottle. It doesn't need to be completely perfect right now. After you glue it, you will be able to bend the wire into the right spot. At the curvature of the bottle, the wire is not wanting to stay perfectly against the surface of the bottle, and we need it to be as close to the surface of the bottle as possible for good gluing. So I'm going to put another piece of tape on the very top side of this to help hold it against the bottle as close as possible. Before I started gluing, I wanted to find out which glue was going to work best for the project. I started off with some Gorilla Glue and it held the wire really strongly to the glass, but it bubbled up and looked terrible. On the second wire, I used super glue and it immediately popped off. For the third one, I used JB Weld Clear Quick Set on top and underneath the wire, and it held it on very tightly to the glass. On the fourth one, I experimented with just using the JB Weld on the underside of the wire, and it came off much too easily. So we're going to go ahead and use the JB Weld Clear on top and underneath the wire. However, my problems with the glue didn't end there. I was now faced with the utmost anxiety of trying to get the perfect proportions of yellow to clear. With the glue mixed up, I used a sharpened bamboo skewer to apply it to the underside of the wire, the top side of the wire, and a little bit of the surrounding area on the bottle. You want to be very careful to try to get the glue only around the wire. It will spread, and if you get it somewhere else on the bottle, it's very difficult to remove and it won't look pretty. With the glue drying, I wanted to see if I could figure out how the power electronics worked. I cleaned off the circuit board and found the names of the semiconductors. Unfortunately, they were made by BPS Semi, which is a Chinese manufacturer that doesn't release datasheets. So sadly, I'm not going to be able to do any sort of circuit modification. However, we can tell that this is a system that converts AC into DC and it probably pumps out a very high DC voltage. So I cut my losses and started working on the magnetic cap for the bottle. Now there's cheap cork and there's good cork. I'm going to be using the cheap cork for this because it cuts a lot easier than the good cork. The idea here is to make the cork easily slide into the bottle, but only slide in about halfway. So I'm going to use my razor blade to cut a line around the halfway mark of the cork. I'm then going to cut up to this point and create the part that's going to slide into the bottle. Initially, I used my razor blade to shape it, but later found out that using my Dremel with a rotary sanding bit was a lot easier. After making sure that the cork slides easily into the top of the bottle, I happily pulled out my favorite tool and got a cylindrical grinding burr. I used this burr to hollow out a section inside the cork so that I could insert a magnet into it. Now that the magnet fits nicely inside the cork, I'm going to use some super glue to hold it in place, and then I'm going to trim off the top as I inset the magnet a little bit too deep. I want to make sure that it looks all nice and flush. In order for the magnetic switch to work properly, we need to know at what distance these magnets start to attract each other. I did that simply by putting the magnet off to one side of a post-it note, bringing the other magnet close to it, and marking the spot at which they got sucked together. This distance now needs to get marked on the bottle so that we know where to position the magnet on the inside of the neck. So with all that done, now we need to figure out where the arm is actually going to seat inside the neck of the bottle. To do that, we're going to take the arm and put it through the receiver, and we're going to leave about a 1/2 inch to 3/4 of an inch gap between the triangle of the arm and the circle of the receiver. I'm then going to take a pair of tweezers and my stickiest foil tape, and I'm going to mark the arm on the spot that we marked on the bottle. This is going to let me know where I need to put my magnet so that when it's hanging down there and I put the magnet into the bottle, it's going to suck the magnet from that spot up. If we put it any lower, the magnet won't be able to get it and won't be able to pull the arm up. I'm sure that sounded a little bit confusing, but if you keep watching the video, you're going to see where I'm going with that. So now I'm going to take the arm out of the bottle, get rid of that stupid piece of tape, and then mark it with a Sharpie. This is the point where I need to position the magnet. To make the next part of the magnetic switch, we need something that will actually hold the arm in the center of the bottle, and I think a piece of cork will do nicely. I'm going to use a real piece of cork here because it actually is compressible and it looks good too. I'm going to cut myself off about a 1/2 inch piece, and I'm going to square it up as much as possible. The problem with this cork though is if we just drill a hole through it and then put the arm through it, it won't slide very nicely against the cork. In order to fix that, I'm going to use an M2 brass insert, drill a hole in the center of the cork, and shove that insert into the center of the cork. That way the arm will have a nice surface to glide upon. To prepare that surface, I'm going to continually step up in size and drill bits until I've removed all the threads from the inside of the insert. I'll then use a flanged grinding burr to bevel the outside edges to make sure that that arm rides up and down smoothly inside that brass insert. If you noticed earlier, I did a horrible job of making sure that the brass insert was properly centered in the cork, but that's okay because we need to sand down the cork so it'll fit properly on the inside of the bottleneck. Using a sanding drum with my Dremel, I began shaping down the cork so that A, the brass insert was more centered, and B, I was bringing the entire size of the cork down. I kept sanding material until the cork was almost big enough to fit in the top of the bottle. This means it should be very close to fitting on the inside of the bottle. Now that I've made the piece of cork smaller, it should fit perfectly through the receiver on the inside of the bottle. I'm going to test the fit using some skewers to press it into place. Here it's a little bit of a tight fit, so I'm going to remove some more material so that it's just a little bit easier. We want it to be a nice firm press fit so that it never falls out, but we don't want it so difficult that we can't take it out ourselves. I removed just a little bit more material, put it back into the bottle, and then I checked it with the arm to make sure that the arm was going to ride straight up and down. Everything seemed like it was going to work out great, so we can move on to the next part. By now the glue has dried enough for me to remove the tape that was holding it previously. I'm going to take special care to make sure that I get glue in the curved part of the bottle, because I need that wire to be pressed up against the wall as much as possible. The glue, while thick, is still viscous enough to run before it sets in that 5-minute window, so I'm going to prop the bottle up so the glue is drying on a flat surface and won't run anywhere. After about 5 to 10 minutes when that glue is set, I can then start filling in the other spots where the tape was. That way the entire receiver is glued on the inside of the bottle and is not going anywhere. While that glue is drying, I'm going to continue with the magnetic switch. I need to mount the magnet in the spot we marked on the arm earlier, but before we do that, we need to make sure that we slide the cork on the arm before we start bending wires. I'm going to build a little cage just by bending wires and mount the magnet inside of it, but make sure that you have the magnet in the correct polarity before you mount it permanently. After about 10 minutes of bending, I had a very secure cage that held the magnet and there was definitely no way for the magnet to ever come out. This entire assembly can now be fitted into the neck of the bottle, and we're going to check a few things to see if it's working properly. The first thing we're going to check is when we put the cork in the top of the bottle, if the entire armature is being attracted upwards. If it's not, you mounted the magnet too far down and you need to shift it up. The second thing we're going to check is to make sure that the magnets are not touching. We're going to have live AC power going to this switch, and I don't want there to be any electrical connection from where your hand is going to the AC. The last thing we're going to check is to make sure that the triangle of the arm is properly seating inside the circle of the receiver. If everything looks great, we can pull it all back out and solder the ends together. And actually, I forgot to mention something. The very last step is when you pull the cork out of the bottle, you want to make sure that the triangle is falling far below the circle so that it's not making any electrical contact whatsoever. Once I've verified the proper operation of the arm, I'm going to solder the two open ends closed to make sure that they don't go anywhere. To create an electrical contact to the arm, we're going to need to add a wire to it, but we don't want a wire that's so heavy that impedes the magnet from sucking the arm up. I'm going to use some stranded 28 gauge wire because it's very thin and shouldn't affect the movement of the arm at all. Here I soldered on a fairly large piece, but then opted to go for a slightly shorter one later on. On the other end of the stranded wire, I soldered on a long straightened piece of 14 gauge copper. This piece of wire needs to be able to go out to the bottom of the bottle because it's going to be glued on the opposing side to the receiver. This is going to be side B of our switch. Now that we've essentially added some weight to the end of the switch, we're going to mount it all again just to make sure that it's still working properly. I did a test fit here and it seemed like the wire I put on was a little bit too long, so I'm going to pull everything out and make it just a little bit shorter. In the end, I used a wire that was about 1.5 inches long. This is going to be our final check of the magnetic switch. Once we get the glue going, there's going to be no takebacks. We are going to glue the 14 gauge wire on the opposite side of the receiver along the groove that runs up the side of the bottle. As before, we're going to use Scotch tape and clear JB Weld to secure the wire to the edge of the bottle. This one I used a little bit less glue because it's not actually holding anything. After gluing, there is one more step that we need to do. We need to make sure that the arm is falling down into the center of the receiver and is not touching the sides of the receiver because we need that off state. If it's not falling properly in the center, use a little hook to bend the stranded wire into the right spot so that the arm falls back down directly into the center of the receiver. With that all done, we can move on to sorting out the LED situation. After going through a few patterns, I finally decided upon this zigzaggy rectangular shape idea. The LED filaments have little spot welded wires on either side of the filament. We need to chop these off before we can do any soldering of the LEDs. The LEDs are very weak and can barely stand under their own weight, so I'm going to use some more 14 gauge wire to create a structure for them to sit on. The 14 gauge wire structure is going to be mounted into our 3D printed base. Now I purposefully did not put any holes in this because I knew it was really easy to come back and drill them out where I wanted them later. I wasn't really quite sure what shape the design would take, and so drilling it just seemed like the best option. I could, however, have put some center lines for me. That would have been really useful. I'm just marking those out with a ruler here. Towards the center of the base, I drilled out 2 holes about a ½ inch apart. I then drilled 2 holes behind those, and I'll show you what those are for in a minute. So here you can see me insert the wire into the hole that I just drilled into the base, and then I'm going to put that entire assembly into the bottle. I'm now going to mark how high that structure can be on the inside of the bottle. The reason for this is we have 2 different circuits that we need to isolate from each other. We have 120 volts running to the bare copper wire that's going to the magnetic switch, and then we also have the DC voltage that is going to the LEDs that's going to be attached to the copper structure. We can't have these 2 touching, it will create sparks and burn something up. So I'm going to give myself about 3/4 of an inch clearance from the stranded wire to the copper structure to make sure that we don't have any accidents. With the wire straightened, I'm going to add a 90-degree bend to it and then insert it into the center hole that I made earlier. I will then use zip ties to go around the 90-degree part, and that will hold it all nicely in place until we can add some glue a little bit later. I'm going to repeat this on the other side exactly the same way. Now we have yet another 2 circuits that we need to isolate from each other. These ones aren't as important as they are at the same voltage level, but I still want to do it just to be sure. I'm going to use a piece of cork and drill some holes into it to make sure that these wires stay spaced apart from each other. Here I'm checking to see what position I want these wires to be at the top to accommodate my LED structure. I think a 90-degree bend will do nicely, so I'm going to make sure to slide that piece of cork on before I start bending, and then I'm going to bend those out at 90 degrees. Once I like how that looks, I'm going to solidify it with what I call devil's glue. This is just CA, it's the super runny kind, and it gets everywhere if you're not careful. And then I use some accelerator to make that all sit tight, and you can see how it started smoking. I thought that was pretty cool. The tower was now ready for some LED filaments, so it's time to begin wiring those up in series. I chose this wacky 90-degree theme that I thought would look really cool if I twisted it around the tower. You let me know what you think in the comments. It's very important to make sure that you wire these LEDs in series. Remember that the LEDs have a little hole on the top to remind you which side is positive. I think attaching these LEDs required equal amounts of art and skill. After I attached them to the tower, I began adjusting the joints with my soldering iron until I got a shape that I really liked. Before I added the connections at the bottom of the LEDs, I put it into the bottle to make sure that it was going to fit in there well and also not contact the stranded wire at the top of the magnetic switch. Based on where the LEDs were hanging at the bottom, I figured out where I needed to add my ground connections. They were in the way of my previous wires, so I just bent those quickly out of the way in the same direction. I then took my drill and drilled out the holes where I wanted the ground wires to be. To make the wiring a little bit easier, I'm going to connect both of the grounds together. I also need to have a support structure that will hold both of the negatives of the LEDs in place. So I'm going to use another bit of 14 gauge wire and bend a little bar that's going to connect both sides and hold the negatives of the LEDs in place. After this, all I needed to do was add a small wire so that I can connect it to the electronics later, and then I connected the negatives of the LEDs to the 2 posts that I just made. And just like the main towers, I added 2 holes on either side of the grounding bar so that I could add a zip tie around it just to make sure that everything was held nicely in place. To make electrical connection easier later on, I added 2 stranded 28 gauge wires to the 2 positive towers in the center. I then covered everything with glue to make sure that those wires were never going to go anywhere and that those towers were going to stand straight and true. To switch the AC power on and off to the lamp, we're going to need to add some wires to the switch that we put in the bottle earlier. Make sure that these wire lengths are at least 7 to 8 inches long. You will see why later. Let's take careful note of where those 2 switches and those wires are, because we're going to need to drill some holes into the base so that we can feed those wires through the base and add electrical connections to them later. We're going to take a small break from electrical work and time to address the aesthetics of this bottle. This 3D printed plastic looks pretty awful, and that is going to get completely covered with this sisal rope. I'm just going to use a hot glue gun and glue the rope down to the base. When gluing the first piece of rope, make sure that it is not larger than the diameter of your base. We still need it to fit inside the bottle. When doing the second layer, we need to make sure that we do not cover the holes that we just made for the wires coming off of the magnetic switch. I'm going to cut the rope into 2 sections, leaving a small slot for the hole for the wires. After we had the slot in place, the rest was fairly easy. Using glue and the rope, I continued to fill in the surface of the base until the entire surface was completely covered in rope. After all the rope has been laid down, we can have a little bit of fun with the lighter and go through and start singeing it. This gives it a really cool aesthetic, and it also helps clean up some of the scraps of hot glue that's left behind. I went a little overkill with the singeing on this one. I wish I'd done a little bit less, but I followed through with it and I think it still looked pretty good. Now the spot on the bottle where we glued the two wires from the magnetic switch looked pretty terrible, so we're going to hide those as much as we can with some rope. The first thing I did was singe them to get rid of all the little frizzy bits, and then I glued them on either side of the wire. This hides the glue and the wire pretty well, and we're also going to address the outside of the bottle a little bit later. Alrighty, we are almost on the home stretch of this bottle. We're going to start assembling everything, but before we do that, we want to make sure that the inside of the bottle is very clean. I used some alcohol and some paper towels to clean out everything that I could. Since I made the 3D printed base a little bit smaller than the bottle, I'm going to wrap the edges with electrical tape so that I can make a very nice press fit on the inside of the bottle. I'm going to check that fit, and it seems like everything was great, so we're going to move on. Before we insert the base into the bottle, I'm going to electrically isolate all of the circuits on the inside, since we have bare copper wire. All I did was just put a couple pieces of duct tape over it. To insert the base into the bottle, we first need to thread the wires from the magnetic switch into the holes of the base that we made earlier. We are then going to begin sliding the base into the bottle until it seats all the way up in its proper position. We can now begin to electrically wire everything together. I'm going to slow down here just a little bit because this part is quite important. The first thing I'm going to do is connect the two hot connections on the circuit boards together. The hot from the AC goes directly to these resistors. The second thing I'm going to do is I'm going to connect the two ground connections for the LEDs on the circuit board. This is not to be confused with neutral from the AC. This is a different circuit. This is for powering the LEDs. Then I'm going to tin the two positive connections for the LEDs, as well as the two neutral connections on the board. We now need to figure out which wire is hot and which wire is neutral. To do that, I put my multimeter in continuity mode. On the plug, the neutral connection is the larger tab. The hot connection is going to be the smaller tab. I'm going to clearly mark this out on the wire so I know which is which. After that, we can put a piece of heat shrink on either wire. And all the wiring fun begins. The first thing we're going to do is we're going to take our hot or live wire from the AC and we're going to connect it to the receiver. Then we're going to run a wire from the arm down to the hot connection on the circuit boards, which is those two resistors. After putting some heat shrink on those connections, we can connect the ground from the LEDs to the ground on the circuit board. This is not neutral, this is ground. It's clearly marked on the circuit board with a little negative. We will then take the two positive wires that are going to power the LEDs and we're going to connect them to the positive connections on the circuit board. They're clearly marked with a plus. The last connection we need to make is we need to connect neutral to both circuit boards. However, the connections for neutral were far apart on both the circuit boards, so I took this little piece of white wire and I made a jumper to go between them. That white wire can then get connected to neutral. Again, we're going to heat shrink and cover everything up as much as possible. My dear DIY friends, please stop abusing your soldering iron and using it to heat shrink. Get yourself a heat gun. They cost $12 at Harbor Freight. Thank you. Like seriously, stop doing it. It's terrible. All right, moving on. We need to get these circuit boards glued into the base, but make sure that you know where the AC cord is going to come in and that your wire lengths are long enough to support where you put them in the base. We are really close to sealing this project up, so I'm going to go ahead and do a really quick check just to make sure that everything is working properly before we start adding in the glue. Now the opening of this bottle was more like an oval than it was a circle, and so I decided later to go in and add a little bit of glue into the cracks just to make sure that that base is held in nice and tightly. And since I'm using hot glue, in case I have any issues inside the lamp, it shouldn't be too hard to take out at all. You can also see that I glued the lamp cord into the base so that we have a little bit of strain relief just in case it ever gets yanked on. I'm now going to seal everything up. 1 week later, the end is finally in sight. What I'm going to do here is I'm going to cover up all of that crappy 3D printed plastic with some more of the sisal rope. Now remember earlier when I was designing this, I said I was going to show you later why I made the base exactly 2 rope widths high? Well, here's why. We're going to be gluing rope onto the base and onto the bottle. I want there to be a seam between the base and the bottle still, even though we're gluing rope on the outside. So that's why I made that exactly 2 rope widths high. Make sure that you put the seams of the rope in the back of the bottle, that way we don't have to see it. You also might notice that I'm doing small sections at a time. This is because the glass cools the hot glue down very quickly and you can only really work with a small section at a time. We're going to keep building up layers of rope until we have covered the base completely. Even though we put rope on the inside of the bottle to help hide that glue seam, it still looks pretty terrible from the outside. So let's go ahead and get that fixed. In order to do that, I need something for the rope to terminate at, so I'm going to make a small little ring and put it just above the magnetic switch so that we can still see what's going on. I'm going to glue that in place, and that's going to be the top part from where my rope seams on the outside are going to join up to. To try to hide the seams on the inside, I'm going to use 3 different sections of rope on the outside. We are going to start with the inner rope and get that very secured onto the bottle. The reason why I'm starting with the inside rope is because it's a lot easier to press the glue into the middle from the outside when we do the other sides of the rope. That way we don't see any of the glue. After that, we can use our lighter, singe the rest of the sisal rope, and make sure we get all the little strands of hot glue off of the bottle. We have just one last thing to do. We need to make sure that that cork doesn't run away from this bottle, because right now it's not attached. In order to do that, I took some of the rope and I extracted one smaller thread out of it, and all I did was use that to tie around the cork, use some CA and accelerator to bond that to the cork, and then I just made a little slip knot, tied it around the bottle, stuck it on there, called it a day. Now our bottle cap's not going anywhere. That was the last and final step of creating our bottle lamp. Thank you for sticking with me. I know this was a very long video and I tried my very best to cut it down as much as possible, but there's just so much information and detail that I wanted to cover to make sure that if you ever wanted to try to replicate this at home, you do so with great results. If you liked this project, please let me know. I would like to hear your feedback. You know where to do that. Anyways, that's been it for this video. I hope to see you guys in the next one.